Now previously we've talked about ratios. Now this time we're going to talk about rates, which are a very special kind of ratio. So what's so special about rates? Well, rates are a ratio where the units don't have to be the same. Ratios have same units, rates have different units, and it allows you to compare quantities of different units. Now you actually have a lot of experience with this. Every time you get in the car, you travel at a speed, and that speed is a rate. It compares two different units, 60 kilometers per hour. This is a ratio that compares distance to hours. You travel 60 kilometers for every 1 hour. If we wanted it to look a little more like a ratio, we never do, but if we did want it to look a little more like a ratio, it would look like this. 60 kilometers to every 1 hour. Different units. You've also seen this when you go shopping. If you're at the local fruit shop and you're buying some bananas, they will cost you $4.99 per kilogram. Now this to me has always been a little bit odd. I'd like that dollar sign to be like right there, so it said $4.99 per kilogram, but that's not how we write it because like maths is a language like any other, and it's a little bit odd sometimes. But it's still a rate. This per this. Now we're going to focus in on one of these particular kinds of rates. We're going to focus in on speed. Now remember, speed is a rate, kilometers per hour. And kilometers per hour is a ratio, kilometers per hour. So we can express it as a fraction. And we can say that speed is equal to distance, in this case in kilometers, over time. In this case, hours. So we've got this great formula here, speed equals distance over time. Now if you want to be really pedantic about it, we should write the word average here. Average speed equals distance over time, because cars speed up and slow down, so what we're interested in is their average speed, not their instantaneous speed. But that's being pretty pedantic, but you should write it in there anyway, because you'll probably get asked about average speeds. So of course, to speed this up, let's just call it S equals D over T, and that formula is going to be really useful. So a quick example, find the average speed of a car traveling 360 kilometers in 4.5 hours. So we know a distance, we know a time, and we want to find the average speed. Of course, we can use a formula that looks like this. Speed equals distance over time. Now the distance here is 360, and the time is 4.5, 4.5. Now of course, we can type that into our calculator. So the answer here is 80. And it's 80 kilometers per hour. And of course, it's not speed, it is average speed. So a second example here, a runner runs 100 meters in 10.49 seconds. Find the average speed. Now again, we're given a distance, travels 100 meters, time 10.49 seconds. We want to find the average speed. Speed equals distance over time. Now the distance here is 100 meters. And the time is 10.49, and obviously we need a calculator now. Now my calculator says 9.532. We're going to move it to 2 decimal places, so we're going to round down to 9.53. Units? Kilometers per hour? No. You need to look at the units that were in the question and use those as your units for your rate. So it was meters, the distance was meters, and meters is what we put up the top, so that's going to be our first unit. And then seconds is what we put in for time, so that's going to be our second unit. They're not moving at kilometers per hour, they're moving at 9.53 meters per second. Now this one's a bit of a head scratcher. Example 3, a car travels 90 kilometers at a speed of 42 kilometers per hour. Find the time taken. Okay, I'm just going to write my formula down. Speed equals distance over time. What do I know? I know a distance. I know the car travels 90 kilometers. So that's a distance. What else do I know? Well, I know that it's traveling at a speed of 42 kilometers per hour. So that is my speed, 42. The thing I don't know is the time. And so now I can do some algebraic manipulation and figure out what t is. Now if I multiply both sides by t, that's going to give me 42t equals 90, because that gets rid of the t on this side. And then I can divide both sides by 42, and I'll get t equals 90 over 42. And I can type that into my calculator. Now my answer is 2.142, and again, that 2 means that I can round down to 2.14. But 2.14 what? It's a time. Is it seconds? Is it minutes? Is it hours? Again, you need to look at the units that were in your question in the beginning. Kilometers, that doesn't tell me anything about time. The rate, however, says kilometers per hour. That means the time in this equation must be being expressed in hours. So it takes 2.14 hours to travel that distance. Now, last thing I'll say, it is a little bit rude to keep this as 2.14 hours, because when it comes to time, we convert things to hours and minutes. I'm not going to do this in this last step. If you want to talk to me about how to convert this to hours and minutes, come and talk to me. All right, that is rates.